Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use the concepts of derivatives to solve this problem. So as per the problem, show that the line 4x minus y plus 11 equals 0 is tangent to the curve y equals 16 over x squared minus 1. So we are given the equation of the line and we have to find that this line is tangent to this given curve. So the first thing we'll do is to analyze the slope of the given line and the slope of the tangent to this curve. So for finding the slope of the line, we'll have to write the equation in slope-intercept form. So currently it's in the standard form. So the general equation of a line in slope-intercept form is y equals mx plus b. So for that, we'll have to isolate y on the left side of this equation. So we will subtract 4x from both sides of the equation so that the 4x's on the left side will cancel out, and we will also subtract 11 from both sides. So the 11's on the left side will cancel each other out. So we'll be left with negative y equals negative 4x minus 11. Now we have to change negative y to y. So we have to divide each term in the equation by negative 1. So the negative y changes to positive y, and then negative 4x changes to positive 4x, and negative 11 changes to positive 11. So this is the equation of this line in slope-intercept form. And as per this form, the slope of this line is 4 because 4 is the coefficient of the x term. Now we have to find the slope of the tangent to this curve. So for that we'll have to find the derivative of the equation of this curve. So we'll start by rewriting the equation of the curve by moving the x squared term to the numerator. So we get y equals 16x exponent negative 2 minus 1. Now we can find the derivative of this function. So we can use the prime notation. So y prime equals, so we have to find the derivative of 16x exponent negative 2. So it will be 16, and now as per the power rule, so it will be negative 2, and then x exponent negative 2 minus 1, and then minus 0. Because 1 is a constant, so the derivative of 1 is 0. Now we can simplify this equation. So prime of y is equal to negative 32 x exponent negative 3. And now we can make the exponent positive by moving the x term to the denominator. So we get y prime equals negative 32 over x cubed. Now in order for this given line to be a tangent to this curve, so the slope of the line should be equal to the expression for the derivative of this curve, because the derivative represents the slope of the tangent. So therefore in our next step we'll sub in y prime as 4 and solve for x. So this is the equation we get, and now we have to solve for x. So the first step is to cross multiply x cubed to the left side. So we get 4x cubed equals negative 32. And now we can divide both sides by 4. So we get the 4's on the left side cancel each other out. So we get x cubed equals negative 8. And now we can change x cubed to x by applying cube root. to both sides. So now on the left side, the cube root and the cube cancel each other out. So we are left with just x equals negative 2, because cube root of negative 8 is negative 2. So as per the slope information that we have from the line and from the derivative of this curve equation, the tangent touches the curve at a point whose x coordinate is negative 2. Now we can find the y coordinate of the point where the tangent touches the curve by subbing in x equals negative 2 in the equation of the curve. So we get y equals 16 over negative 2 squared minus 1. So we get y equals 16 over 4 minus 1, because square of negative 2 is positive 4. So we get 16 divided by 4, which is 4 minus 1. So y equals 3. So that means, as per the slope analysis, so the tangent touches the curve at point negative 2, comma 3. Now we have to check whether this is a point of intersection between the line and the curve. So for that, we'll analyze the two given equations. So we have 4x minus y plus 11 equals 0 as the equation of the line, and we had changed it to y equals 4x plus 11 in the slope intercept form. And the equation of the curve is y equals 16 over x squared minus 1. So we find the point of intersection by making the two equations equal to each other. So we get 16 over x squared minus 1 equals 4x plus 11. Now we can simplify this equation by getting rid of the denominator x squared. So we multiply each term by x squared. So the x squares with the 16, they cancel each other out. So we get 16 minus x squared equals 4x cubed plus 11x squared. And now we can move the x squared minus x squared to the right side. So we add x squared to both sides. The x squares on the left side cancel each other out. So we get 16 equals 4x cubed plus 12x squared. Now we can move the 16 to the right side. So we subtract 16 from both sides. The 16s on the left side cancel each other out, and we get 0 equals 4x cubed plus 12x squared minus 16. So this is the equation we get when we set the two equations equal to each other. Now we have to check if whether this point that we found from the slope information, does it satisfy this equation. So we sub in x as negative 2 and we see whether the left side becomes equal to the right side. So we sub in x as negative 2. So 4 times negative 2 cubed plus 12 times negative 2 squared minus 16. So we get 0 equals 4 times negative 8 plus 12 times 4 minus 16. So 4 times negative 8 is negative 32, and then 12 times 4 is 48, and then minus 16. And when we combine these numbers, we get a 0. So the left side becomes equal to the right side. So that means the graph and the line, they intersect each other at point -2, 3. So this proves that the line 4x minus y plus 11 equals 0 is tangent to the curve y equals 16 over x squared minus 1. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to understand that we have to analyze both types of information to prove that the line is a tangent to the given curve. One is the analysis for the slope and the other is the analysis for the point of intersection between the line and the curve. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.